This is your activity walkthrough to help explain the pnorm and qnorm functions. On screen 1, you have to explain what pnorm does. In order to learn more about pnorm, just go to R, find the Help section, and type in pnorm. You're told that this is for the normal distribution, that we have actually 4 different functions: dnorm, qnorm, pnorm, and rnorm. The arguments used in these functions, the first one is either an x or a q, which stands for quantiles. If the function takes a p, that stands for probability, or if the function takes an n, that stands for number of observations. In any case, the mean can be specified using the word mean and standard deviation using the word SD. By default, they are set to 0 and 1, the mean and standard deviation of the standard normal distribution. Also, we have log and log p that are true. If the probabilities are given as a log, we will not use this in our course. And finally, lower tail, true or false. If it's set to true, it means that your probability is always less than an amount given. So lower tail means less than by default. Lower, less, they match up. Otherwise, if it's set to false, you're finding probabilities greater than that number. By default, lower tail is set to true, so you're looking for values less than by default. If you want to answer the question, what does pnorm do? Pnorm gives the distribution function for the normal distribution. And you could share that with the class. Next, what does qnorm do? You just go back to the documentation, and qnorm is meant to give you the quantiles. It's still for the normal distribution, so you'd still have a mean, standard deviation, lower dot tail for if you're looking for probabilities less than or greater than, and you could share that with the class. If we keep going, we're going to do a bit of a demonstration with these functions. What is the probability of z being less than 1.96? You're going to set z to 1.96 and then just look at the number you have here. It's about 0.975 or 97.5%. So the probability of being less than 1.96 is this blue shaded area. It's about 97.5%. Now we're going to go in R and use this exact command. pnorm 1.96, mean of 0, standard deviation of 1, lower tail true. When you put that directly in the console, look what you get, 0.9750021. How is that related to what we had on the previous slide? 0.9750021. It gives you the probability. So by typing in the z-score inside of pnorm for the standard normal distribution with 0, 1, you're getting the probability of being less than 1.96, or this shaded blue area. That's what the normal distribution pnorm function is giving you. So what does it give you? It gives you that the area or probability of being less than 1.96 is about 97.5%. Now, what if we keep everything else the same but change lower tail to false instead of true? Go back to R, type that in, and you get 0.025. That's about 2.5%. But what is true about probabilities? They always have to sum to 1. So if lower tail true gives you everything less than 1.96 in this blue area, what lower tail false is giving you is this part that's greater than 1.96. This leftover area or probability in the white here. So less than 1.96 is about 97.5%. Not less than 1.96 is about 2.5%, this leftover in white. So how does it change your answer? It gives you the probability of being greater than 1.96 instead of being less than it. This is about 2.5%. Then, let's look at another situation. What is the z-score that would correspond to a probability for the 90th percentile? So if I change the probability to 0.9 for the 90th percentile, see my z-score is about 1.28. That's appearing here. So what happens if I use the function qnorm and that 90th percentile as the very first argument? Then I've got my mean 0, my standard deviation of 1 for the standard normal, and lower tail true, which is the default. I get 1.281552. qnorm gives the z-score for the given probability / percentile. So for the 90th percentile, the z-score was about 1.28. Then we would go on and we want to change this one more time by changing lower tail to false. And let's see what happens. All that happens when you change it to false is it flips it and gives you the negative z-score instead. So if you look at the picture, basically lower tail false is the z-score that would have 90 percentile above it instead of 90 percentile below it. So that would be this, negative 1.28. 10% below, 90% above is what you get with lower tail false. For lower tail true, what you get is the z-score, about 1.28, that has 90% below and 10% above. They're just flipped. Because the normal distribution is symmetric, you get this flip. It gives you the negative z-score instead. And that's your quick review of the pnorm and qnorm functions. To quickly summarize, you use pnorm for the type of questions where you have a z-score and you want to find the probability of either being less than or greater than that z-score. On the other hand, if you have a probability and you want to find the z-score, that's when you use qnorm. So if you have the area under the curve and you want to figure out what the z-score is that corresponds to that, we called these working backwards questions in the last lesson. That is when you use qnorm. So pnorm is used when you want to find a percent. qnorm is used when you have a percent and you want to find a z-score.